You know that feeling, right? You buy something sturdy, heavy denim, maybe thick cotton, looks like it's built to last. And then, almost straight away, something tiny fails. The zipper pull snaps off, or maybe a button just rips right out. We focus so much on the fabric, the textile, but honestly, so often the lifespan of clothes hangs on these little bits, the buttons, snaps, elastic buckles. The industry calls them trimmings, I think. Okay, let's unpack this then. Today we're doing a deep dive into, well, the tiny world of quality assurance. Our mission really is to get our heads around these standard, sometimes pretty intense methods manufacturers use, just to make sure these small components don't let you down. Because, let's face it, if the zipper breaks, that expensive jacket, pretty much useless no matter how great the leather is.
Yeah, and what's really fascinating, I think, is just how much scientific rigor goes into making sure something simple, like a buttonhole, performs consistently over time. So our source material for this deep dive, it comes from research that was actually put together for a book project, Strong Seams, all about garment durability. But here's the interesting part. We're digging into the notes, the research that was, believe it or not, initially seen as too detailed for the final book.
Wait, hang on. You're saying this is the stuff they cut out because it was too technical for an already technical book on garment quality?
Exactly.
Wow. Okay, that tells you something, doesn't it? About how deep the standard industry expectations actually go.
Yeah.
So we're not just looking at basic guidelines here. This is like the hidden science that stops your clothes falling apart at the seams. Literally.
Precisely. We're exploring the unseen criteria. Think of them as the three main pillars of quality control for these trimmings. They ensure longevity, function, and safety too, for you, the person wearing it.
Okay, so let's get into that roadmap, this science of durability. You mentioned three main tests. That's right, we're focusing on the three most common ones: the pull test, the fatigue test, and the stretch test. Right. Let's start with the one that, well, sounds like it just makes sure things don't fall off. The pull test. Exactly. The pull test. It's really fundamental because it tackles two big things at once: the strength of the connection, its integrity, and also physical safety. The name seems so simple, though. Like, I just picture someone literally yanking on a button. But what's the actual, standardized test here? What's being measured?
So the pull test is specifically designed to check the strength of the connection. It's not really testing the fabric itself or the button material. It's testing the anchor point. And this applies to basically everything that's meant to be permanently attached. So snaps, Velcro patches, if they're sewn on, buttons, and those really critical points like where a shoulder strap attaches or even a zipper pull tab.
Okay. So a button sewn on, the test is actually stressing the thread, the stitching.
Yep.
Not the plastic or metal of the button itself.
Precisely. And the way it works, the core mechanism, involves putting these accessories under a specific measured force. They measure it in pounds or newtons, and they hold that force for a set amount of time. Usually, they use calibrated equipment to apply the stress really consistently. The whole point is to find out its resistance to breaking, or actually more commonly, just detaching from the garment, ripping off.
And I'm guessing these forces aren't just random numbers. They must relate somehow to real-world stress, right? Like if I snag my sleeve on something, that sudden pull.
Oh, absolutely. They simulate that kind of thing. And this is where standardization really matters. For high-quality stuff, manufacturers use specialized testing gear. I mean, sure, you can do basic manual checks, just pulling. But for real precision, you need things like handheld pull gauges or even these bigger tabletop pull test machines. These machines make sure the force is applied just right, perpendicularly, consistently. It gives you objective, certifiable results.
That's really useful info for anyone looking for genuinely well-made clothes. But you mentioned safety earlier. How does the pull test connect with, like, strict safety rules, especially for certain types of clothing?
Right. This is where it goes beyond just durability and becomes a must-do for regulations. It's especially stringent, incredibly important for children's clothing, infant wear particularly. The amount of force needed to pull off a small component isn't just a suggestion. It's often mandated by safety standards around the world.
Because a detached button or a bit of zipper? That's a potential choking hazard for a small child.
Exactly that. If that tiny part comes off with a force a baby could realistically exert, determined pulling or tugging, then the whole batch fails inspection. The standards, the required force, they're set really high to give a big safety margin. So this test isn't just making sure your sweater lasts, it's literally trying to prevent that hazard from existing in the first place.
Okay, that really puts the pull test in perspective. It's like the first hurdle. Is this safe? Will it stay attached? But if something passes that, does that automatically mean it's good for the long haul? Or is there more to test once you actually start using the item?
That's the perfect transition because, yeah, staying attached is one thing, staying functional is another. A button that just sits there, it just needs to hold on. But what about something that moves constantly? Zippers, Velcro, things you use dozens, maybe hundreds of times. For that, you need a completely different kind of test. Which brings us neatly to the second pillar.
Right, simulating actual wear and tear over and over again.
Yes, exactly. The fatigue test. This one is absolutely crucial for any component that gets a lot of use. Primarily, that means zippers, some kinds of adjustable fasteners, and definitely Velcro. It's all about checking sustained functionality.
Okay, fatigue. We're talking about just repeating an action until something gives out, right?
Right.
So how do labs standardize what counts as typical use? I mean, a jacket zipper is used differently than, say, a Velcro strap on a shoe.
They base it on the expected life cycle of the product and what it is. So the process involves putting the accessory through a set number of cycles, a predetermined number that mimics how it would normally be used. And this is where some of the numbers from our source material get quite interesting. Like for a standard zipper on a jacket that gets, say, medium use, they might test it by zipping it up and down maybe 50 times, pretty rapidly.
50 times. Okay, that might not sound like a huge amount over the entire life of a jacket, but I guess doing it 50 times under controlled, machine-driven conditions, that probably induces stress much faster than normal use.
That's the idea. You're essentially condensing maybe months or years of wear into just a few minutes of intense testing. If it holds up to 50 tough machine cycles, it strongly suggests it'll probably survive hundreds, maybe thousands of less aggressive cycles when you're actually using it. And think about the difference between zippers and Velcro, too. For Velcro, the fatigue test is more about the grip strength, the shear force. So they repeatedly attach it and detach it. And they're watching, do the little hooks and loops start to flatten out? Do they break? Does it lose its ability to grip properly?
So if you've got a high-end jacket, maybe it has 10 buttons, 2 zippers, the maker has to run these cycling tests on every single type of component, potentially hundreds of cycles for each batch. That sounds like it adds up time and cost-wise.
Oh, the cost is definitely significant. But for brands that pride themselves on quality, it's non-negotiable. Because failure here, that means instant customer complaints, returns, damage to the brand reputation.
What exactly are they looking for in that inspection phase?
They're hunting for any signs of trouble. Visible stuff like, is the fabric fraying around where the zipper is attached? Are there cracks or any kind of warping in the plastic or metal parts? And most importantly, any loss of function. Does the zipper start to snag? Do the teeth misalign? Does the Velcro just not stick well anymore? If any of that happens, it fails the fatigue test. It ensures the accessory doesn't just stay put, but it actually works like it's supposed to, hopefully for the entire expected life of the garment.
It really makes you appreciate the engineering behind something as seemingly simple as a good metal zipper. It has to handle all that repeated stress, friction. Okay, let's pivot to the last test category. We've covered things staying attached, that's the pull test, and things opening and closing, the fatigue test. What about materials that are meant to stretch and change shape, right? That brings us to the third one, the stretch test. This is obviously vital for anything using elasticated materials.
Could be a flexible strap, maybe one of those bungee cord locks, or just the elastic that's woven into a cuff or a waistband to make it snug. This test basically figures out if that flexibility is functional or if stretching it is just going to lead to it failing quickly.
So what are the specific properties they measure? It can't just be how far does it stretch before it breaks, can it? No, it's more nuanced than that. You're really testing the molecular integrity of the material when it's put under stress. It looks at 3 key things that are all related: elasticity, elongation, and recovery.
Okay,
can you break those down a bit? Elongation, elasticity, recovery.
Sure. Think about a regular rubber band. Elongation is simply how far you can stretch it out from its normal resting size. Elasticity is that inherent quality it has that lets it store energy while it's stretched. It wants to go back. And recovery, this is the really crucial one. Does it actually snap back perfectly to its original size and shape when you let go? You know, if you stretch a rubber band too much or too often, and when you release it, it's just saggy. Longer than before. It's failed the recovery test.
Oh, yeah, I've definitely had elastic waistbands that failed that recovery test spectacularly after just a few months. They just go permanently slack.
Exactly. So the standard method involves stretching the material or the accessory to a specific extent, often something like 150%, maybe 200% of its original length. And they hold it at that stretch for a defined period. This is usually done with a machine, a tensile testing machine, which applies the force very consistently and measures the stretch precisely and also how quickly it recovers.
Okay, and unlike the fatigue test where you're checking if it still grips or slides properly,
Yeah.
here, with the stretch test, you're checking the actual structure of the material itself while it's stressed. What are the key things they inspect afterwards?
Yes, exactly. The inspection targets two critical areas. First is fiber breakage. They are literally looking, often under magnification, for tiny breaks or fissures within the elastic fibers themselves. If those fibers start breaking down prematurely, well, the material's integrity is shot, and you get that permanent slackness you mentioned. The garment loses its fit, its function.
Right. And the second inspection point, that sounds like it comes back to the connection again, doesn't it?
It does, yeah. The second check is on stitch strength, because you can have the absolute best, most resilient elastic in the world. But if the stitching holding it onto the main garment fails when you stretch the elastic, the whole thing comes loose anyway. So they check that the seams are secure, that they won't unravel or loosen right at that point where the stretchy part meets the non-stretchy fabric. Both the fiber integrity and the stitch security have to pass.
So putting it all together then, the pull test, the fatigue test, the stretch test, what does it all add up to? It's like three different scientific angles on just one garment's details.
It means that real quality control goes way beyond just, using a thick thread or a tightly woven fabric. The combined purpose of these tests is to build a complete, rigorously tested profile for durability and safety. They make sure those small bits, the critical moving parts, the anchor points, are tough enough to handle everything thrown at them, being pulled on, moving constantly, stretching dynamically, all throughout the product's intended life.
In connecting this to the bigger picture, these simple-sounding standardized tests, they're kind of the unseen, often mandatory steps that separate true quality from, say, fast fashion. It explains why a garment with lots of specialized trimmings, maybe technical outdoor gear or workwear costs more, but you expect it to work perfectly for ages. These three tests cover every connection, every moving part.
And going back to that initial point we made, the fact that this level of detail, checking for fiber breakage, measuring forces in newtons, counting test cycles, the fact that this was seen as too much detail, even for a technical book like Strong Seams, that's really telling. It just highlights this baseline level of technical rigor the industry kind of expects or requires, but that stays completely invisible to us as consumers.
Yeah, think about that hidden work, that accountability. You never see the lab report, but somewhere one exists, proving the zipper on your coat was pulled and cycled way harder by a machine than you'll probably ever do yourself.
Which kind of raises an interesting question, doesn't it? What level of complex, careful manufacturing steps and scientific testing do we just routinely take for granted every single time we put on a piece of clothing that actually lasts? We just assume a zipper will zip and that a button stays on. But behind that simple assumption, there's all this specialized testing, expensive machinery guaranteeing that function. Just consider how much unseen effort goes into making sure your simple elastic waistband snaps back perfectly, time after time.